Welcome everyone. Today this is the first class of CCNP switching. So first guys, like as I told you to join this course, okay, make sure you have a like basic CCNA level knowledge, like how to give the IP addresses to the router, switches and VLANs क्या होते हैं, subnet mask क्या होता है, okay. And so in this course, like we will cover CCNP switching and CCNP NRC, which is basically routing, okay, from the scratch. Let's start the first class, okay. The first guide, like we will cover like Cisco Catalyst 9000 switches, because these days, guys, like companies are using a model of switches, okay. क्योंकि जो आपके earlier model थे, like 3700 and 6500, वो क्या obsolete हो चुके हैं. और दैट्स वाई कंपनीज गाइज क्या कर रही हैं, अपने स्विचेस को क्या कर रही है, माइग्रेट कर रही है. सेकंड गाइज, लाइक वी विल आल्सो कवर लाइक कंपनी लैंड डिजाइन. तो कंपनी में जो स्विचेस हैं, देखो ये कैसे इंस्टॉल होते हैं. एंड देन थर्ड गाइज, लाइक वी विल सी द layer 2 communication. And after that, guys, we will cover the VLAN. The first guy, like if we see this Cisco Catalyst 9000 switches, okay. So these are the switches, guys, like we use in enterprise network. Okay? So don't confuse with like Cisco Nexus 9K, because Nexus switches, guys, they are used in data center, and these switches are used in enterprise. यहाँ पे आपके क्या user बैठते हैं offices में. The first guy, like if you see 9200 and 9300, these is guys like mainly they use for access layer and distribution layer. यहाँ जिस पे क्या आप अपने end devices क्या connect करते हो. And then we have like the other model, okay, which is basically used for a core layer. And so इस केस में गाइस, like you see like main difference क्या है, जो Cisco जो ने ये नए मॉडल इंट्रोड्यूस करे हैं. फर्स्ट क्या है गाइस, हाई पोर्ट डेंसिटी होती. तो अभी जो आपके अपलिंक पोर्ट होंगे वो 40 GB या 100 GB सपोर्ट करेंगे. अर्लियर गाइस पहले क्या होता था, जो अपलिंक पोर्ट होते थे वो क्या होते थे, मैक्सिमम 10 GB स्पीड. And further guys, like you ये Cisco के switches हैं. So the iOS version we are seeing in this model iOS XE. So we'll see like a difference क्या है. So like especially जब हम इनको अपग्रेड करते हैं, and इन switches को guys आप CLI भी मैनेज कर सकते हो और GUI, ओके. तो GUI बेसिकली गाइस क्या, सेंट्रलाइज एक आप डीएनए के थ्रू सारे स्विचेस को मैनेज कर सकते हो. बट मेनली गाइस हम इन स्विचेस के ऊपर क्या है, CLI ही देखेंगे, ओके. और प्लस गाइस लाइक जो रेस्ट ऑफ टॉपिक है, लाइक VLAN, STP, HSRP, ईथर चैनल, ओके, दोज आर द सेम. सो कोई कॉन्फ़िगरेशन वाइज कोई डिफरेंस नहीं है. एज लॉन्ग एज अगर आपको पहले पता है ईथर चैनल कैसे कॉन्फ़िगर होता था, लाइक 3700 पे या 4500 पे, सेम कॉन्फ़िगरेशन गाइस जो सिस्को के जो स्विचेस हैं इनके ऊपर भी कॉन्फ़िगरेशन क्या, लॉजिक क्या, सेम है. एंड इफ यू सी गाइस लाइक these switches they divided like similar like earlier we have a fixed switches and the modular switches. So modular switches guys क्या होता है, इसमें जैसे पहले 6500 आता था, उस पे आप लाइन कार्ड क्या कर देते थे, इंसर्ट कर देते थे. And these are like on the other hand like 9300, 9200 and the 9500, these are the fixed switches, okay. So this is the guys like the picture of like one of like 9500, जो कि हम कोर के लिए यूज करते हैं. And you see guys like ये जो सिस्को का स्विच है 9500, so the port only support only QSFP, not SFP. So SFP का like जिसकी स्पीड क्या होती थी, 10 Gbps होती थी. और जो QSFP है, so this is a picture of QSFP, okay. तो ये आप इस पोर्ट पे क्या है, इंसर्ट करते हो और उसके बाद क्या आप फाइबर केबल कनेक्ट करते हो. So the way basically they use the setup, okay guys, like as I told you, तो 9500 क्या है आपका जो स्विच है वो क्या है, कोर में यूज होता है. और जो 9300 है वो किस लिए होता है, जहां पे हम एंड डिवाइस कनेक्ट करते हैं. तो इस 9300 पे भी क्या है, हम मॉड्यूल इंसर्ट करेंगे. आई विल शो यू इन द नेक्स्ट स्लाइड, ओके. तो ये जो मेरा पोर्ट होगा, अपलिंक पोर्ट, यानी कि जो कि कोर की तरफ जा रहा है, दैट विल सपोर्ट अ स्पीड ईदर 40 और 100, ये डिपेंड करता है द QSFP यू आर यूजिंग अ सिंगल रेट। सिंगल रेट गाइस क्या होता है, अगर आपकी QSC या 40 सपोर्ट करेगी या 100, और दिस QSFP इफ यू सी दिस इज अ ड्यूल रेट। ओके, ड्यूल का मतलब क्या है, डबल, इधर ये 40 करेगी या 100। तो ऐसा नहीं है आप इस कहते होते हैं पोर्ट पे आप स्पीड 10 GB कर सकते हो, नहीं, ये सिंपली ड्यूल रेट ही सपोर्ट करती है। और कई QSFP आती हैं, तो दिस इज द पिक्चर ऑफ द QSFP, पिक्चर आपकी सेम ही रहेगी। और इधर अगर आप सिंगल रेट परचेज करते हो तो सिंगल रेट में आपको 40 GB मिल सकता है या 100 GB मिल सकता है। तो जो अपलिंक पोर्ट होंगे वो क्या होंगे, लाइक एक मेरा अपलिंक कोर 1 की तरफ जाएगा और सेकंड मेरा अपलिंक किसकी तरफ जाएगा, कोर 2 की तरफ जाएगा। अगर इफ यू यूजिंग लाइक से 9300X, तो जो ये पोर्ट होंगे नीचे जो एंड यूजर की तरफ जा रहे हैं, दैट इज 10 GB पोर्ट। Because these days guys, like definitely everybody need like higher speed. That's the major difference you will see on the new Catalyst 9000 series. Okay, but not every 9300 providing that much speed. Okay, depend करता है if you purchasing X model, so X model guys, yeah, for the end machine, like जो जितने भी Ethernet port होंगे ये सारे 10 GB होंगे। अगेन दीज आर मल्टी रेट पोर्ट, आप इन पोर्ट को 1 GB भी कॉन्फ़िगर कर सकते हो, 2.5 भी कॉन्फ़िगर कर सकते हो, तो 10 GB भी कर सकते हो, दैट इज अ मैक्सिमम। सो अगर पोर्ट के ऊपर अगर आपको ऐसी स्पीड दिख रही है, मैं आपको दिखाऊंगा, लाइक 1 GB, 2.5, देन मे बी 10 GB, दिस पोर्ट इज नोन एज मल्टीपल रेट। अगर आपको दो ही रेट दिख रही है, दैट मीन्स दिस पोर्ट सपोर्ट ड्यूल रेट। अगर सिंगल दिख रही है तो वो सिंगली सपोर्ट करेगा। ओके, सो दिस इज लाइक here on 9500 we can only use QSFP. Then guys, if you see, this is the next model, like which is like I told you we use in access layer, which is 9300X. So this is a 9300X series switch. So this is the front side. So front side, like these are Ethernet port, which is port multiple rate. Okay, and the maximum speed is 10 GB. And this is like where we can insert the module. And this module basically used for uplink. Depend करता है, if you need only 2 uplink, maybe you will buy this module. Okay? And it's very easy to install this module. Okay, just ये आपको अगर यहाँ पे बटन दिख रहा है, if you click this, okay, ये module क्या out हो जाएगा, यानी कि इसको आप बाहर निकाल सकते हो। एंड बेस्ड ऑन रिक्वायरमेंट, अगर आपको 10 GB के पोर्ट चाहिए, देन यू विल बाय दिस। maybe let's say you have a switch, okay, and you want to connect this switch to the firewall, and the firewall support only 10 GB, then in that case might be you will buy this module. Because this will provide you guys fiber port. So again here guys, like these are the blank, so you need to insert this QSFP, sorry, SFP. Okay, so this is a SFP which support 10 GB speed. If you see like 10 GB and it's showing SR, so SR means guys like short reach. So definitely guys, not only like the configuration perspective troubleshooting, we will also see like some hardware troubleshooting perspective. In case, let's say if you connect your fiber link from 9300 to 9500, and in that case your fiber port is not coming up, what's your troubleshooting step? Okay, similarly, like when you connect the Ethernet cable to any end device, if your port is not coming up, what's your troubleshooting step? Okay. So we will also cover those things. And then the high availability perspective, okay, like HA, these switches, okay, like the 9300, they support switch stacking. So just like a 3700, 3800, those switches earlier support stacking, and 9300 and I believe 9200 also support stacking. And my core layer switches, okay, they are not coming with the stack port. This port, just like if you remember in 6500, 4500, we cover VSL, virtual switch link, sorry, VSS, virtual switch system. And in here, guys, like you will see the similar kind of feature, which is stack wise virtual, okay, SVL. So later on, guys, like we will see why we use this, okay, basically, especially when we want to use the MLAN, multi-chassis ether channel. So same guys, like same thing आप achieve कर सकते हो in new model के ऊपर भी. Okay, and those guys, like maybe in CCNA you don't study what is stack, what is VSS. No worry, guys. Like when we cover the ether channel topic, I will cover this. Okay. So this is, guys, like the switch stack. So as I told you, we will touch this part later, but right now, like we are focused on like how the company basically built the LAN design. Okay, how they basically make the LAN design. So in this course, guys, like all the practical we will do on EVE-NG. So in this diagram, I just connect the switches and I just connected these end machine. Okay. So I haven't done any configuration on those devices. So first, guys, like we will see like why I made this design. Then we will configure the IP address to these end machine, okay? And we will see the traffic flow. The first, guy, like if you see, I only use 2-layer, okay? Like this is like known as core layer. And this is known as access layer. Maybe in CCNA, you study like 3-layer LAN architecture. And here, guys, like I'm using only 2-layer architecture, okay? So first, guys, like if I tell you, okay, like why we use this architecture, okay? So you see, like when you install the core switches, okay? So let's say this core switch has 48 port. So 48 port, when you connect, like let's say any one switch, let's say this is port number 1, and I connect another switch, and this switch also has 48 port. So what we are doing? So basically we are extending this from one port to another 48 port. That means like on this switch, we can connect multiple devices. So this is basically the use of switch, right? So switch basically, like in CCNA you study, switch has higher port so that you can connect end user, end machine. So it could be like your laptop, your printer, your phone, okay? Or any audio video device, okay? So via using this design, basically I'm extending each port to another 48 port so that I will get additional port, okay? And the benefit of like getting additional port, ताकि मैं अपनी end machine क्या मैं ज़्यादा connect कर सकूँ. So it depends like how big is your network. Maybe if you apply the 3-layer architecture, in that case you will get additional LAN port, and maybe in future your network will be grow. So maybe you will use this scenario. Okay. So you have a like core, you have a distribution, you have an access. Because if you see this design, so single port further extended to 48 port, and even this switch port also further extended to 48 port. And ultimately you will get like more port and you will connect more devices, okay? So these days, guys, like you see, like depend on the company size. So most of the company, like where I work, okay, I see in only this design, core and access. And again, it depend your company size, okay? अगर आप maybe जिस company में आप काम कर रहे हो, you have a like large number of end user, and maybe you are using 3-layer architecture, okay, like for distribution, then access layer. Okay. So here, guys, like as I told you, I haven't done any configuration. The first thing we will understand how the communication happened. So we will have a port machine. Okay, so these are basically I'm treating as a machine. Even in my diagram, these are showing as a router. So like जैसे आप machine के ऊपर क्या आप IP address देते हो. So I'm going to give the IP address like 1.1/24 और जो मेरा ये सिस्टम है पोस्ट 3 इसके ऊपर मैं IP एड्रेस दे रहा हूँ 1.3/24. द पॉइंट इज लाइक राइट नाउ एज यू नो स्विचेस के ऊपर क्या होता है बाय डिफॉल्ट दे आर बेसिकली sharing the same broadcast domain which is VLAN 1. Okay, तो उस केस में guys like you will use the same IP schema. So you know like if you like in CCNA you study like how we basically use the design. Okay, so every VLAN basically equivalent to subnet. So let's say we have a like VLAN 1. And for VLAN 1, we are using this subnet 1.0/24. That means all my PC, they are in this subnet, okay? So again, if you have, let's say, another VLAN and VLAN 10. So for VLAN 10, I'm using this subnet 10.0/24. So all my PC which are in VLAN 10, they will basically use this subnet. Okay? So this is like I seen like not every company they use the IP schema like this because this is very easy to remember. Okay, if you see maybe you are designing the IP schema and so first two digit, okay, this will tell the location. Okay, let's say you have office in Delhi, so that means like every Delhi location IP address start from these two octet. Okay, and third number basically that define the VLAN number. Similarly, let's say you are designing the network for designing the IP schema for your another office. Let's say your Bangalore office. Bangalore office, like first two octets start from 116. Then third octet start from which is VLAN number. Okay. So, I mean, like if you design like this, let's say you're designing any company network for the IP schema, it is easier to remember like when any new engineer, okay, join your network or join your company. Because this is the first thing, okay, like when we joining any company, okay, we will first understand the IP address and the network diagram. So here, guys, like as I told you, these machine basically I'm treating as an end machine. And I'm just only giving the IP address. Okay, so let's say this is my host one. So host one, guys, like we will configure the IP address. So in window machine, guys, like we will configure the IP address to the adapter. Okay, which is like ncpa.cpl. So this is my like adapter. This is my Ethernet adapter. So if you see, I have given the IP address this. So this is also a router. So on the router, this is the interface. Okay, NIC card gigabit 0x0, and I'm going to give the IP address. Okay. So in this case, like the IP address is gigabit 0x0, no shutdown, and IP address is 192.168.1.1, 255.255.0. To just only give the IP address, I'm not defining any default gateway. You see like on a window machine. So we define not only the IP address, we also define the default gateway. So this is like we also define the default gateway. But on this machine, I don't need to define the default gateway because right now we are only using the same subnet communication. Okay. So same subnet communication troubleshooting, different subnet communication troubleshooting. Okay, we will discuss. So No. So we cannot use a loopback here. We'll talk about loopback later. But right now, why we cannot use a loopback? Because this is a NIC card. Okay, think like that. This is a NIC card. This is the NIC card connected to the switch. Okay. So machine end user, okay, they normally has two NIC card, okay. Like I mean, like, it can be more, but the point is like the end machine, the laptop. So laptop, either you can connect the your network through the Ethernet cable, which is your LAN cable, or Wi-Fi. So this is the NIC card connected to my switch. So definitely we will give the IP address to this NIC, okay, not a loopback. So here, guys, we give the IP address to host one. And now let's configure the IP address to this host, okay, which is host 3. So host 3 interface is gigabit 0y0. Interface gigabit 0y0. No shutdown IP address 192.168.1.3. Again, we on the switches, we are not configure any configuration. So these switches like work as a dummy switches, okay. So dummy switches basically you cannot create any VLAN. They are sharing the same segment. So right now, guys, these switches are also sharing the same segment. Okay. So the first thing, guys, like in the layer 2, what we require, okay. So make sure like every end user, they should be in the same subnet. So in our case, they are, and they should participate in the same VLAN, okay. And by default, as I told you, all the switches port, they are using VLAN 1. So if you check the connectivity, okay, the way we check the connectivity through via ping, so ping 192.168.1.3, and you see the first packet is drop because of R, and we have a reachability. We have a reachability, and this first packet only drop first time, because once we learn the MAC address, okay, show IPR. So this is the command to see the R table on the router. On the window machine, the command is R-A. This is the command. So when you communicate within the LAN, within the same subnet, you will see in the R table the entry of the destination IP. You can see like to reach this 192.168.1.3, this is my destination IP, which I was pinging, and I can see the MAC address. But we will see like when we communicating the different network IP. So for the different network IP, you will not see the MAC address entry for that IP, okay. So let's say if you say my system is communicating to the Google, let's say if I say ping www.google.com, so I can ping the google.com IP, it's IPv6 IP. Let me force to use the IPv4. So here, guys, like, so not only, guys, you need to focus on like a router, switches, firewall, but you also need to know the basic command of end machine. So end machine like a Windows, Linux, or Apple. So let's say on this window machine, if I say how to do ping, how to check the R table, how to check the routing table, definitely, guys, we will cover that. Because you see, like when you get any issue, even the issue on the end machine, I mean, like let's say any network setting on the end machine, normal user or any other user, they don't know any network setting about the end user also, end machine also. So you as a network engineer, okay, it's your responsibility, make sure the PC has proper default gateway, PC has proper DNS, PC has like, let's say if they are doing some routing on the Windows machine or Windows server or Linux server. So the basic command of networking, you need to know on Windows, as well as Linux. Okay. Especially these are the main operating system I have seen use even on a server side. So most of the server guys, they use Linux. So we will also cover that, okay? Like the Linux basic command, networking command. But you see, like I told you, like this is the way to check the ARP table. And here, guys, like if you say you can use help, okay? Like the way we use help, okay? Like in Cisco, I show you, we use the question mark here, like /, then question mark. So this will tell you, like if you want to send the continuous ping, then use -T. If you want to see it resolve the IPv4 address, so you can say, okay, I want to ping the Google, but I want to seeing the DNS, okay, hey, use IPv4. You see, like this now, this time, by using this option, okay, by using this option, what is this ARP in window? ARP. So how layer 2 communication work? Okay, so in CCNA you studied what is ARP protocol. So as I told you guys, every device, okay, every network device जिस पे हम आईपी एड्रेस देते हैं उन सब पे राउटिंग टेबल होता है, आर्प टेबल बनता है, हर एक डिवाइस पे बनता है। ऐसा नहीं है सिर्फ आर्प टेबल राउटर पे बनेगा। तो हर एक डिवाइस पे जो नेटवर्किंग कर रहा है, यानी कि जो कम्युनिकेशन कर रहा है, जिसके ऊपर आप आईपी एड्रेस दे रहे हो, डिफॉल्ट गेटवे दे रहे हो, उन सब पे आर्प टेबल बनेगा। So by using this keyword, okay, I'm telling DNS use the IPv4 address. Okay, you see like this is a Google IP address. I can reach the Google IP. So in that case, the source IP is my IP, the destination IP is Google IP. But if I check the ARP table, okay, this is a command to check the ARP table, ARP-A. I don't see the entry for Google IP. So later on, guys, like maybe if you don't like properly study in CCNA how the communication work for different subnet, because for the different subnet, we don't send the R packet, we only send the R packet to my default gateway. Okay. Okay, coming to the layer 2 communication, guys. So layer 2 communication, we don't need a default gateway. So in that case, you see, like this is my IP, this is the destination IP, and for the destination IP, we are seeing the MAC address. So if you see this diagram, guys, so to reach from this machine to this destination, okay, so this is my source IP, which is 1.1. My destination IP is 1.3. So if you see the traffic flow, we have two paths. So first, guys, this PC obviously send the traffic because this PC has only one interface card. This PC send the traffic through this NIC card to this switch. And this switch might be send the traffic to the core one. And then the core one send the traffic to access switch 2. And then the access switch 2 send the traffic to this end PC. This is the first path, okay. The second path might be the end machine send the traffic to this switch. This switch might be send the traffic to the core 2, and the core 2 send the traffic to this access switch, and then this switch, okay, send the traffic to this end PC. So now we will see by default to communicate from this system 1.1 to 1.3, switches are using black path or pink path, okay. So this is, guys, like basically known as layer 2 tracing. So you need to trace out, okay, what is your actual path. So right now I'm showing you, okay, because switches basically, guys, like forward the traffic based on MAC addresses. So, and by default, and switch is basically forward the traffic based on what? Based on destination MAC. So let's understand, guys, let's understand. So you see, this is my system. So this system, when sending the traffic, okay, you use source IP. So this is a layer 3 header and the layer 2 header. So in the layer 3 header, the main thing is source IP 192.168.1.1. This is your source IP. And destination IP is 192.168.1.3. Then you have a source MAC. So source MAC will be, if you see, let's assume A, and destination MAC is, let's assume B. So switches, they will forward the traffic based on this header, okay? And they will see the destination MAC, and based on destination, they will find out the leaving interface. So I hope guys, like let me show you basically switches, they will forward the traffic based on destination MAC address. Router, they will forward the traffic based on destination IP. So if you see guys, like in our scenario, what is source MAC, destination MAC? This is mainly what we care, okay? Because we have like switches installed and they are forwarding traffic based on the destination MAC, okay? So if you see guys, like on this end machine, okay, this I'm going to this host one to find out the MAC addresses. So if I copy this output, and now we know basically what is a MAC address, and this is the destination MAC address. So I copy this MAC address, and if you see this diagram, I'm asking to switch three, hey, tell me if this is a destination MAC, where you leave the traffic, through which interface, okay? So we have two interface, the leaving interface, either gigabit 0 via 1, 0 via 2. And if we ask the switch, okay, show MAC address, and either here you can press enter, but I want to show you, like, let's say you are only finding the path for particular one MAC address. So address, you can define the destination MAC. So it will show you guys the leaving interface. So right now, guys, I don't see any leaving interface, because if you study CCNA, okay, in CCNA, there is like aging time. So if there is no traffic for any MAC, okay, for a 5 minute, that's the aging time, which is like 300 seconds, your entry will be gone in the MAC table, okay. So by default, switches has like aging time, MAC address table aging time, which is by default is 300 seconds. So if we don't have any activity, okay, for those MAC will be gone, okay, or flush in the MAC table. Okay. So let me initiate the traffic again. So let me initiate the traffic from host 1 to host 3. So ping 192.168.1.3, and I can ping the IP. And if I again ask this switch, okay, switch 3, I know the MAC address of the 1.3, okay, which is this guy. Now you can see that to forward the traffic to this destination MAC, I will send the traffic to this interface, okay. So that means which is our black path. So when the traffic received from this PC, it will basically forward the traffic to gigabit 0 via 1, which is going to core 1. If you see the diagram. And might be guys, like you have a doubt, okay? I mean, like you have a question, like here you have a diagram and you can easily track, okay, like gigabit 0 by 1 going to the core 1. In the real world, guys, like you don't have view to this topology, okay? Like let's say you are working in a company and you want to find out this communication, okay, like from source to destination, and you see from source to destination, both are in same segment. In middle, how many devices are coming? So we will see later on, okay, like how basically you can make your diagram without seeing any document or any logical diagram. So I will also teach you, okay, how, because once you know this, okay, you can easily discover the any company network, okay. Because in some company, like when you join, okay, maybe they will not give you the network diagram. but based on the source and destination IP, okay, you can make the diagram your own, okay. So you don't need to depend on them. So here, guys, like basically we have a diagram, okay, and clearly saying gigabit 0 by 1 is going to core 1, okay. Then on the core 1, we will run the same command. So here, guys, like you see, the core 1 has obviously, the core 1 has only one leaving interface, because in switching, when we receive the packet, we never send the same packet on the back interface, okay, because that obviously causing the loop. So in this diagram, like switch has only one leaving interface, which is this interface, and the core 1 switch basically send the traffic to this switch, and then this switch basically send the traffic to this side, okay, because this is the end machine where it is directly connected, okay. So like if I ask the core, okay, because right now, if you see the diagram, core has only one leaving interface, but if we run the same command, okay, like this is the command, and if we're going to the core 1, okay, and asking the core, hey, to forward the traffic to this destination MAC, what is my leaving interface? And you can see that the leaving interface is gigabit 0 by 1, which is going to this switch, okay. This is a leaving interface which is going to this. And then the traffic will basically reach to my end machine, okay. So any question, guys, up to this point? It's a basic thing, okay? Yeah, any question up to this point? No question. Okay. If you don't have any question, let continue the class, okay? So the next thing, guys, we will also see how we can play with the traffic engineering. So what is, guys, traffic engineering? Okay, so traffic engineering basically, right now you see the traffic flow from this PC to this PC. This is the path. But let me give you like the requirement or the scenario. Hey, I don't want to use this path. Okay, make sure when the host 1 communicate to the host 3, I want to modify the path. This is, guys, known as traffic engineering. I want to prefer, instead of this path, okay, I want to prefer this path, okay. So this is, guys, like layer 2 communication. So layer 2 communication, again, same subnet communication, okay. I hope, guys, आपको पता होगा what is same subnet. So same subnet, guys, like you see, in our case, the source IP is 192.168.1.1. The destination IP is 192.168.1.3, and we have the subnet mask, which is /24, which tell this portion is your network portion. This portion is your network portion. And if you see source and destination, they both basically having the same network portion. That means they are in the same subnet. And different subnet, guys, like maybe if I give you the same example, okay, 192.168, let's say 4.1. If I say 192.168, 10.10, 10.1. So you cannot say based on the IP address, this is the same subnet communication or this is a different subnet communication unless you don't know the subnet mask value, okay? If let's say for source and destination IP, you are using /16, that means this is your network portion. Again, this is the same subnet communication, okay? Because the network portion is same, okay? So same subnet communication happened through the switches, okay? Not through by the layer 3 device, okay, or router. Okay, so now moving to the next topic in VLAN, in switching, which is VLAN. So here, guys, like I want to create the VLAN. I don't want to use the same broadcast domain. So what I am doing here, okay, I'm configuring the system in VLAN 10. And these two systems I will configure in VLAN 20. Okay, so first guys topic is how we create the VLAN. This is next topic. Then how we assign the port to the VLAN. So VLAN. Then we basically talk about switch port. Okay, so switch port basically like mainly guys you will see in the real world access type or trunk. So this is the next topic. And then we will see more in like switch port, okay, like in real world, how to configure the trunk port, how to configure the access port, okay, like especially like on the access port, what kind of configuration we will do, okay. So let's configure the VLAN, okay. So in this diagram, like as you know, I want to create a VLAN and I want to assign this end machine to the VLAN, okay. So first guy, like obviously you need to create the VLAN on all the switches, okay? And I'll tell you the reason why, okay? So let's say on this core, I'm using creating VLAN 10. So it's up to you, okay? Let's say if you want to create the multiple VLAN, okay, together, you can use this dash value, let's say 10 to 20. What this command do, okay? This command basically create the VLAN 10 to 20. Or if you want to create the VLAN, let's say that the VLAN range is not in sequential order, you can use comma. But normally, guys, like we also define the name. Let's say this VLAN for my Wi-Fi user and VLAN 20. This VLAN is for my LAN user. Or the next VLAN maybe printer VLAN, or some of you have a security devices, security VLAN. With the reason, once you create the VLAN, show VLAN. So any new engineer, okay, come, they will, you let's say you are connecting any new device, they will maybe send you the ticket. Hey, can you put this device in Wi-Fi VLAN, in Wi-Fi? So that means, you know, like for Wi-Fi, this is my VLAN. Okay, that means I need to assign this port VLAN tag. So normally, guys, like obviously, and machine might be like this port is going to your access point. So we'll see, but I'm just telling you the purpose. Okay, in the real world, definitely the way you will configure the VLAN, obviously you will, because the name itself telling the purpose of the VLAN. So similarly, guys, like on core 2, I'm just creating the VLAN, okay, 10 or 20. So VLAN 10 and VLAN 20. And if you see, guys, like VLAN question mark, so the maximum range is VLAN from 1 to 4094. It actually basically, guys, start from like 2 raised to power 16. So the VLAN range is 0 to actually range 4095. So this is like the theoretical part. The reason I'm covering this, okay, those who want to give the certification, okay, after this course, CCNP, NRC or switching, yeah, you can do that, okay. So these number are reserved. So you cannot use this starting just like a network ID and broadcast ID. The rest number is from 1 to 4094. And again, this range further divided into two parts. One is the normal range. So the normal range basically guys like 1 to 005, and then the extended range, okay, which is 1006 to 4094. So I see guys like this is the range normally I see in like ISP use. And this is the range like used for like enterprise network. Or, but it's not necessary, okay. So you can use even this higher range. I see like the way the enterprise company, they design the network, okay. Let's say if you purchasing any WAN link and this is your LAN. For the LAN, might be you're using normal VLAN range. And let's say if you want to configure, assign this port in a VLAN, your WAN link, okay. For the WAN link, might be you use your extended range. Just to like easily or to understand, or maybe like any other engineer come, okay. So this is the way maybe you design your network. So for LAN, we are using normal VLAN range. For the WAN range, we are using this extended range, okay. So here, guys, like simply as I told you, we want to create the two VLAN, and I just did okay. I believe like I already created the VLAN 10 or 20, and then I need to configure the VLAN on my access switches also, which is VLAN 10 and VLAN 20. This is my second access switch, VLAN 10, 20. VLAN 10, VLAN 20. Okay, now once we create the VLAN, next step is assign the VLAN to the port. So on switch 3, this port gigabit 0 by 3, I want to put this system in VLAN 10, and this system I want to put in VLAN 20. So the way, guys, like we will do this command, okay? So technically only single command required, but I will tell you we need to configure one more command. So technically, guys, like if we want to assign a VLAN to any port, okay, only this command is enough. So let's say gigabit 0 by 3, as per my requirement, this port should be in VLAN 10, and this is the only command, switch port access VLAN 10. And if you see the just configuring this command, show interface gigabit 0 by 3, you can see note this output show VLAN brief. You can see this port now participate in VLAN 10. And if you see the configuration, only single command. But in CCNA, you also seen, okay, we could configure one additional command, which is gigabit interface gigabit 0 by 3 switch port mode access. So now, so you need to understand, okay, make sure the way you study, okay, so you need to understand what is the exact purpose of the command. Okay, let's say I'm configuring this command, what this command is doing, and if I'm doing this command, then what this command is doing. Okay, so that is the approach, okay, you need to follow, because if you follow this approach, okay, believe me, your basic will be very strong, okay, and once your basic is very strong, you can easily do a troubleshooting. So if you see, like the reason we use also this command, by default, every Cisco switcher port, okay, running protocol, which is a DTP, dynamic trunking protocol, every switch port, and every 30 seconds, we are sending this hello message. And what does the DTP protocol do, okay? It's a CCNA topic, but still I want to cover this. So first, like sending the every DTP message to the end machine, this is unnecessary. This is the basis of bandwidth. You don't want to send a DTP message to the end machine, because if you say, let's say I will show you, let's say on the another port, on gigabit 1 via 0, I want to configure this port in VLAN 20, and I'm not using this command. Okay, so what this command do, guys, basically switch port mode access, this will disable the DTP. So any port which has this command, that means DTP is disabled. So gigabit 1 via 0 switch port access VLAN 20. And if you see show DTP and let's say enter. So right now this switch has 8 port using DTP. Every 30 seconds we are sending this hello packet. But if you see the show DTP interface gigabit 0y3, this port is basically not running DTP, okay? Because on this port, we disable the DTP via configuring switch port mode access command. Because we don't require the DTP to end machine. Basically, what guys earlier DTP do, okay? So in DTP, it automatically configure the trunk port, okay, between switch to switch. Again, even I will show you, we will not use the DTP for the trunk port also, because sending the packet every 30 seconds, okay, this is unnecessary. So the recommendation, okay, even you are using the trunk port, I will show you how to configure the trunk port. And then we will also see some troubleshooting step, okay. So the point is, guys, like on the access port, the port which is going to the end machine, normally we use these two commands. One is switch port mode access and other is assign the VLAN. So in this case, like if you see, we have a 2 access port. One is this, which has we configured 2 command, and one is this, where we have configured only 1 command. So now let's configure the interface gigabit 1 via 0. The other command to disable that DTP, switch port mode access. Okay, now as per the requirement, I have configured this PC in VLAN 10, this PC in VLAN 20, and the same here, guys. Or going to the other switch and assigning the configuration. So interface gigabit 0y3, switch port mode access VLAN 10. Then interface gigabit 1 by 0, switch port mode access VLAN 20. Done. Okay, now what is a trunk port do? Okay, so trunk port will carry the multiple VLAN traffic. So PC10, PC20, PC10, PC20, how they communicate, okay? When they send the traffic to this switch, okay? So now either of this link or this link, they will carry the traffic for VLAN 10 as well as 20. So think like that, access port only carrying the one VLAN traffic, trunk port carrying the multiple VLAN traffic. So switch to switch, we always has trunk port. Okay, so switch to switch, we always has trunk port. That means I need to configure all these port as a trunk port. Then we will configure the IP address as per our IP schema, and we will check the connectivity. So let's configure the trunk port. And this is my first class, so I'm not going very deep in detail, but tomorrow definitely I will show you some of the the troubleshooting command of the trunk port as well as the access. So I will also confuse you, okay, because it's only not only the real perspective, but even if you planning to give exam. But the reason, guys, those who are working, maybe they don't need to give the certification, but those guys who are new, they don't have any motivation, okay? So just set a goal, okay? Let's say I want to do the CCNP certification. So you have a set the goal. तो उस केस में गाइस क्या आपको मोटिवेशन मिलेगी तो आप पढ़ोगे इस केस में, ओके? जो वर्किंग है वो ऑब्वियसली उनको क्या अपनी कंपनी में इशू सोल्व करने हैं, तो उस केस में गाइस वो डेफिनेटली क्या वो पहले से मोटिवेट है, ओके? So coming to the guys the trunk port, okay? Now on this switch, we are on this switch, okay? Switch number 4, which is access switch 2. So gigabit 0y2, 0y1. So these port I need to configure the trunk port, and the way we configure the trunk port command is gigabit 0y1 switch port mode trunk. Okay, here guys, this is a layer 3 switch. And I believe like, in the new iOS, okay, you don't need to define the trunking encapsulation. So to configure the trunk port, okay, first we need to define the trunking encapsulation, which is two protocol, okay. One is ISL and .1Q. So these days, guys, like Cisco iOS new version, okay, they don't support this version. So you don't need to use this command. But this is the old version, okay? In the older version, first you need to define the trunking protocol, which is .1Q. Then you can define the switch port mode trunk command. So yeah, I will cover more regarding this trunking protocol, but this is the command. If I show you the command again, show run interface gigabit 0 2, I use two command, okay, which is switch port trunk encapsulation .1Q and switch port mode trunk. The same command, guy, like I need to configure on between all the switches. Then we will see the we will check the basically connectivity and see some show important command, okay, and understand the output of those show command. Okay? So first, okay, like, let's say I will configure all the switch port, okay, interface gigabit 0 2, switch port trunk encapsulation .1Q, switch port mode trunk. So this switch we has done the configuration. Then moving to switch 3. So you can guys also use a range command. So let's say if you want to configure multiple port together, obviously guys, like that means like आपको क्या same ही configuration करनी है. So उस case में guys like gigabit 0 via 1, then 2 अगर वो sequence में है, अगर sequence में नहीं है, then you will use a question mark, comma. So here guys like gigabit 0 via 1, 2 switch port trunk encapsulation .1Q, switch port mode trunk. Now moving to the core. So core interface range gigabit 0 via 1, 2 switch port trunk encapsulation .1Q, switch port mode trunk. Going to the core 2. Interface range gigabit 0 via 1, 2 switch port trunk encapsulation .1Q, switch port mode trunk. Okay, so as per the requirement, guys, we have done the configuration. So let me again tell you, okay, like what we did. So these all port are working as a trunk port. Trunk, trunk, trunk. I will show you the verification command. And these port we configure as an access, 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 access. So because switch to switch, we want to forward the traffic for all the VLAN. In our case, we have a 2 VLAN 10 or 20, but access port only carrying the 1 VLAN prop. You can verify it, okay? Like let's say if you go to any switch, so switch 3, show interface trunk. Guys, here you will see like which are the port working as a trunk port. So you need to understand this output, okay? First, you see like these two ports working as a trunk port. And this is my trunking protocol. Earlier, guys, like we have ISL. So ISL, guys, basically they are no longer used. I'll tell you why. But by default, guys, your trunk port this is carrying all the VLAN information. So this is like carrying all the VLAN information. But right now, only in my database, like show VLAN, I have only these 3 VLAN. And on these 2 ports, the spanning tree forwarding state, this is like very important, okay, when we cover the spanning tree, like because spanning tree, like maybe in CCNA you study some of the port blocked by the spanning tree, but on those 2 ports, we are forwarding the traffic for those VLAN. So guys, this end line is very important because this is basically decide मैं इन VLAN का traffic carry करूंगी. So I will show you guys like maybe later on when we configure the manual pruning or either STP blocking some VLAN traffic. So this is the end line decide मेरे को इस पोर्ट पे किस किस VLAN का ट्रैफिक फॉरवर्ड करना. Okay, so again guys, like if you see show VLAN brief में अगर आपको यहाँ पे कोई पोर्ट नहीं दिख रहा है, से अगर आप देखो you are not seeing the port gigabit 0 wire 2 और 1, that means क्या है, वो सिंगल VLAN का ट्रैफिक कैरी नहीं कर रहे. Those are the port working as a trunk port. They are not participate in a single VLAN. Okay, they are basically forwarding the traffic for multiple VLAN traffic. So if you don't see your connector port here, that means those port working as a trunk port. Okay, now let's give the IP address as per the IP schema and check the connectivity. And behind the scene, guys, I will tell you how exactly they communicate. Okay. So let's go to the core one, okay? Sorry, and machine. And the way, guys, like I want to use the IP schema. So we have a two VLAN 10. Let's say for VLAN 10, I want to use this IP schema 1.0 because I already give the IP address to my two system, okay? 1.1 and 1.3. For VLAN 20, I want to use the IP schema 192.168.2.0. So this is the IP schema for VLAN 20. So two system, we already give the IP address. Now going to my second host, which is in VLAN 20, I will use the IP schema interface gigabit 0 via 0 IP address 192.168.2.1 and host 4 interface gigabit 0 via 1 no shutdown IP address 192.168.2.2. Okay, let's check the connectivity. Okay, do we have connectivity to 192.168.2.1? Again, this is the same subnet communication. So we are sitting on host 4. We are sitting here and we will check the connectivity to host 2. Okay, so here again, this is guys, same VLAN communication, VLAN 20. Okay, traffic will go here, might be traffic sending to this core, then core sending the traffic to this access switch, and the access switch sending the traffic to this system. Okay. So if we carrying the VLAN traffic end to end, okay, on this path, so we should have communication. Okay. So let's see the communication. Okay. So do we have reachability? We have. So the way, guys, this communication work, okay, let me now tell you end to end, okay. So you see, so when this PC send the traffic, because end machine, they don't know, okay, they don't know we are in which VLAN. When traffic received to this interface, okay, this interface configuration check, okay. I'm in VLAN 20. So in the layer 2 header, they will add the VLAN bit, okay, which is earlier I told you guys, like I said 2 power 260, no, 2 raised to power 12. This is the actual VLAN bit value. That's why VLAN range is from 0 to 0495 because VLAN bit is basically only 12 bit. So VLAN, you can say VLAN header. Okay. Carrying the VLAN header on this Ethernet port, okay, I need some protocol, which is in trunking, they use .1q. So .1q is basically used because Ethernet, they don't have any thing, okay, to carrying this VLAN value to the other switch. That's why we use trunking protocol .1q to carrying the traffic, to carrying this VLAN bit value with another switch. So that's why, okay, like if you're using the trunk port, okay, make sure the trunking protocol should be same on the both side. Okay. If you're using ISL and .1q, they will not work, okay. बट आजकल ये प्रोटोकॉल यूज ही नहीं होता क्योंकि जब ये इथरनेट हेडर में गई, जब ये .1q टैग लगाते हो तो इसकी जो हेडर का साइज है वो 4 बाइट का है। और जो ISL था पहले वाला जो ओल्ड, उसका 30 बाइट। ओबियसली जितना आप हेडर लगाओगे, लाइक आपने CCNA में पढ़ा होगा, इनकैप्सुलेशन डीकैप्सुलेशन, हर एक लेयर कैसे अपनी इंफॉर्मेशन ऐड करती रहती है। तो जितनी ज़्यादा आप ये इंफॉर्मेशन ऐड करोगे तो जो आपका डाटा है उसका साइज कम होता रहता है। ठीक है, डोंट, नहीं, जो जिनको नहीं पता इनकैप्सुलेशन डीकैप्सुलेशन क्या होती है, CCNA की मेरी OSI लेयर की वीडियो देख लेना। हर एक लेयर क्या अपनी इंफॉर्मेशन ऐड करती है। तो इस केस में गाइस, लाइक अगर मेरे को ये VLAN टैग लेके जाना है तो मेरे को .1q टैग लगाना पड़ेगा। तो सिमिलरली इस तरफ भी क्या है, .1q टैग। जब यहाँ पे पैकेट रिसीव होगा, क्योंकि ये मेरा क्या है, ट्रंक पोर्ट है, ये करेगा .1q टैग को कर देगा, रिमूव कर देगा। और जैसे ही ये रिमूव करेगा, इस स्विच के पास रह जाएगा सिंपली VLAN टैग वैल्यू, जो कि सिर्फ 12 बिट की होती है। देन ये स्विच चेक करेगा, ओके मेरे पास कौन कौन से पोर्ट VLAN 12 में है। Then I will send the traffic to only those port. So in our case, this is the PC in VLAN 20, तो ये ट्रैफिक इस तरफ जाएगा। तो यहाँ पे देखो ट्रंकिंग .1q का टैग इंसर्ट होगा, यहाँ पे क्या होगा, रिमूव होगा। जब ट्रैफिक इस इंटरफेस पे जाएगा तो दोबारा री इंसर्ट होगा, इनकैप्सुलेट होगा, अगर यहाँ पे होगा डीकैप्सुलेट होगा। डीकैप्सुलेट होने के बाद स्टिल इस स्विच के पास क्या रह जाएगा, VLAN टैग वैल्यू विच इज 12 बिट। ओके, और फिर ये चेक करेगा हाउ मेनी पोर्ट पार्टिसिपेट इन VLAN 20, आई विल ओनली सेंड द ट्रैफिक टू दोज पोर्ट। ओके, क्लियर गाइस? और एनी क्वेश्चन, वेरी बेसिक, ओके, यू कैन सी अप टू CCNA लेवल तक। कोई ज्यादा बेसिक तो नहीं हो गया? हाँ जी, क्वेश्चन, स्वीट क्वेश्चन।
हेलो सर। हेलो
यस यस यस।
सर, ये अभी मैं कोर्स ले चुका हूँ ना, उसके एडिशनली कुछ होगा क्या यहाँ पे, मतलब बोलोगे या तो? वो रिकॉर्डेड सेशंस लिया था
हाँ भाई,
मैंने।
इसमें मैंने पहले शायद आपने देखी नहीं डेमो वीडियो, इस साइड हमें अलग वो कंटेंट अलग है।
मतलब वाईफाई भी कवर होगा क्या सर?
हाँ जी, अलग कंटेंट है भाई, तूने शायद डेमो वीडियो देखी, यूट्यूब पे डाल रखी है मैंने।
अच्छा अच्छा।
जो मैं पढ़ा रहा हूँ उसमें क्वेश्चन पूछू पहले तो भी। Okay, if you don't have any question guys, then I'm going to end the class। और जो इंटरेस्टेड है गाइज वो मेरे को पिंग कर सकते हैं, और टुमारो क्लास ज्वाइन करने से पहले फीस का जिसको नहीं पता वो मेरे को पिंग कर सकता है, तो आपको फर्स्ट इंस्टॉलमेंट देनी पड़ेगी कल की क्लास ज्वाइन करने से पहले, ठीक है? ओके देन गाइज, सी यू टुमारो।